Welcome to Introduction to Microservices Architecture Basics course. I am Mustafa Rifat. I have been designing and developing software solutions for more than 20 years. I'm a published author and I acted as a referee for the IEEE Software magazine. You can find more information about me on my LinkedIn profile or on my blog. In this series, you will learn all the principles of building software with the microservices architecture approach. What is microservices? Microservices is a software development technique, a variant of the service-oriented architecture (SOA) architectural style that structures an application as a collection of loosely coupled services. In a microservices architecture, services are fine-grained and the protocols are lightweight. The benefit of decomposing an application into different smaller services is that it improves modularity. This makes the application easier to understand, develop, and test. Microservices is basically service-oriented architecture done well. People always concentrate on micro in the microservices architecture, services architecture. But microservices is just a term. It doesn't mean that the services are tiny. It just means the services provide one set of functionalities that are highly correlated and interdependent, i.e., it cannot be divided into smaller components. Microservices parallelizes development by enabling small autonomous teams to develop, deploy, and scale the respective services independently. It also allows architecture of an individual service to emerge through continuous refactoring. It also enables continuous delivery and deployment. A typical SO service looks something like this. Because there was no guidance in the past on how to size a service and what to include in a service, traditional service-oriented architecture resulted in large components that are inefficient to scale up and change. Also, SO services used to have a common data store or database to share data between the components or services of the system, and relied heavily on the ESB or the Enterprise Service Bus, a heavy middleware piece to connect services and sometimes implement some of the business logic or a service. While a microservices application would be composed of multiple services, each service will provide a set of related functionalities. A microservice has a single focus. It does one thing and it does it well. Microservice architecture uses lightweight communication mechanism between different components, either between client to services or between service to client to service. No centralized middleware anymore. A transaction within a microservice-based system is a distributed transaction which is completed by multiple services. The application interface for a microservice needs to be technology agnostic, as each service can be built using a different technology stack. Each microservice has its own storage. Each service is completely independent. It has its own technology stack, Java, .NET, and a data store, and it's independently deployed. Notice I'm using the term data store, which can mean relational database system like Microsoft SQL or Oracle, or a NoSQL store like Hadoop, for example. There are many reasons why the microservices architecture are popular these days. For example, you can change or modify the microservice quickly. The rise of the domain-driven design, the availability of automated testing tools. Microservices architecture transactions are distributed, and so a transaction will be processed by several services before it's complete. The integration between those services needs to be tested, and testing these microservices together manually might be quite complex task. Actually, it is. Release and deployment of microservices is also complex, but there are tools that can carry out these functions. So the availability of tools for testing and deployment. And most importantly, the need to adopt new technology quickly. Because the application is composed of several independent parts, you can easily change one part or introduce a new component as a microservice to get new technology and a competitive edge for your application. The rise of asynchronous communication makes microservices possible. When you use distributed transactions, the distributed transaction might use several services chained together to complete one transaction. Using asynchronous communication, the originating service doesn't have to wait for individual services in the chain to complete their task before it's complete. We will talk more about this in later in the series. An application that has microservices-based architecture has the following benefits. Each service is relatively small and easy to manage and evolve. It is easy for a developer to understand and get started quickly with good productivity. Each service can be designed, developed, and deployed independently of other services. This provides agility as it is easier to deploy new versions of that microservice frequently. It allows to scale out individual areas of the application. The application infrastructure will be much more efficiently used when scaling out than a monolithic application would be, because you don't have to scale things that doesn't need to be scaled out. By dividing the development work between multiple teams, each team can manage, develop, deploy, and scale their service independently of the rest of the other teams. Issues are more isolated. If there is an issue in one service, only that service is initially impacted, and other services of the application can continue to handle requests. You can use the latest technologies because you can develop services independently. Each team is kind of free to start using the latest technologies and frameworks that it wants.